Uh, yes. Okay. So, what we're doing now, I've decided to move away from using multi-threading because it's unnecessary. For what I'm doing, I really don't need it. And instead, we're going to use the select function to check if the socket has something going on, and if so, then we're going to act on it. I was going to do non-blocking sockets, but I don't think I need to. I think I can get away with blocking sockets with what I'm going to be using this for. So let's get to it. Yeah. Found an example implementation here. So what we're gonna do then, it's actually gonna be quite a bit of work. So first we need the actual select method. So if we go to TCP socket here, we're gonna have select, and this returns an int. Okay, so it's going to be select. We're going to pass in a TCP socket, sock, and then there's going to be some other stuff as well. We have the read set, the write, and then the other one. Let's just do Windows first. So it'll be if we're in Windows here. So if we're in Windows, we're going to be doing this. I don't know if... yeah, we'll see. Okay, so it's just an FD set, right? FD set, read FDs, write FDs, and the accept FDs. So it'll be the same, and this is a pointer to an FD set. Right. So here's where they're doing select here. We have an FD set. Okay, so FD set. Why do they have an uppercase here? Okay. Well, we'll see. So we have the read FD set, or I could maybe just kind of go with their naming, I suppose. Read set, write set, and then accept set. So okay, this is going to be interesting because for Windows and Linux, this is going to be very different. Let me open this up in here and let's see. Right, so we have select sock, we have the read set, the write set, and then the accept set. Yeah, it is FD set, that's right. Yeah, okay. FD set. Okay. All it is it's just a set. How many sockets are in the set, and then the actual array of sockets, and then they have this size of 64. Okay. Okay. And then there's a timeout value as well. And what I'm going to be doing is so you just pass in the null pointer if you don't care about that. Right. This is a pointer. It's a pointer, so you just pass in null pointer if you don't care about that. I'm actually not gonna care about the except set either, so I'm gonna omit that because we just if we don't care about it, I'm not gonna include it. We can always add that back later. So read set, write set. We do that. Now I think this is gonna be very similar, if not identical, for Linux. Do I want to worry about that right now? Let's take a look. We have select, include sys select. Okay, so it should be in a different select. It is different. It is different. So we still have the read set. It is called FD set. That's the same. So read FDs, write FDs, accept FDs, and it's the same thing. Timeout. It's just what's NFDs there. That's a bit strange. This argument should be set to the highest numbered file descriptor in any of the three sets plus 1. That's very strange. That's very strange. On error, -1 is returned. Okay, I'm thinking let's leave. This is the Windows implementation. Let's leave the Windows implementation for now, and we can come back and we'll add the Linux version later. I think we should have, if select had an, I think we should change this. If an error occurs, we could return true or false. I think this is going to be a bool. So select, and then here we're going to have what's it returning? Return the number of file descriptors contained in the 3 return descriptor sets. The return value may be 0 if the timeout expired before any file descriptors became ready. I think if we pass in null, there's no timeout. So on error, -1 is returned, and error number is set to indicate the error. So if it's -1, then there's an error for Linux. Let's just see. Let's just see how this goes here. So I think we would say int number of sockets, I guess, right? Number of sockets. And then here we could say sockets. I think it's going to be the same. The only difference is I think it's the same. I think this is the same. I think what we're doing differently is just checking what the error state is. So for on Linux, we're checking if the number of sockets is -1, then that's an error, right? So we return false, an error occurred. Otherwise, we return true. So an error occurred, and the last error is str error, right? And then for Windows, we're checking something else, right? If this is equal to, is it socket error? Technically, we could move these down. So, do this. If it's socket error, the last error is that. Linux, we check if it's -1, and it's that, and then either way we return false. Otherwise, we return true. And we set num sockets to be num sockets. Yeah. Okay. Let me just check that that's correct. There's a total number of socket handles that are ready and contained in the FD set structure. 0 if the time limit is expired, or socket error if an error occurred. All right, so we're checking if it's equal to socket error. Okay. Yes. Okay. Instead of numbers ready, we could say number of sockets. Num ready, maybe. Right. Num ready. Num ready. Oh, and this is also num ready. This. Hopefully I didn't fuck anything else up there. Numbers ready. Okay. And we may need to include select, I'm not sure. We'll have to test that out. Well, we can test that out now, actually. So if Fenrir runs, we're still good to go. Okay. And now I'm gonna do yeah. Um, mm, we only get warnings. Yeah, and I'm fine with that. So I don't think we need the. That's kind of weird. So I don't need to include select then. It's strange. Maybe because it's not actually being used, and so the compiler's not even including it. But we'll get back to that in a second. Okay, so now we have select for Windows and Linux. Okay, let's get back to Fenrir. So how are things changing now? No. Okay. So how are things changing? So we initialize our TCP. We bind this socket. So we have a listen socket, bind it to this port, so that creates the socket and binds it. We then start listening. This is where things change now. This is where everything changes now. So we don't just accept a connection now because this is blocking. What we're gonna do, while true, is we're gonna call select. So if TCP socket select, we're gonna pass in the listen socket. Now here's where we need our, I think I'm only gonna have read set, read FDs, read FDs. I'm gonna pass a null for the write, and then I believe that's it, right? So if this happened in printf, failed to select, failed on select. Failed on select. Right, I can put a string, and we can say TCP socket last error. Has to be a C string. Right. So if we fail on the select call, then oh, and there's also number ready. So select, read FDs, we do this. Read set, write set. I'm going to call them read FDs and write FDs. Read FDs, write FDs, and then number ready. Number ready I think is good. So we have the number ready to do this. Now what do we do? Now what we do now is we first check is the, okay, before we even get to this, we have to actually create our sets. So, Yeah, we need to create our sets like this, right? So it's an FD set. So we have a read set, write set. We have an FD set, and then we can zero it out. And I think that's all described in here as well. Yeah, FD 0. Initialize the set to the empty set. We can remove a socket from a set, and then it takes a pointer. We can is set checks if it's a member of a set, and then adds a socket to a set. So what we do then is we say FD 0, and we zero out the read FDs, which would be here, right? Is it just an FD set? Is that what it is, right? Read set. Constantly changing the name of these things. It's just the read set. I'm constantly changing the name of this. So we have the read set, right? We zero, well, when we come in here, we zero the read set, right? Clear it. And then we're gonna add, well, for sure we're gonna add the listen socket. So FD, how do you do this? FD set. It adds a socket to the set, so the listen socket. Add that to the read set. And this has to be a pointer, right? Yes. We set that. So clear it. We add the listen socket to the read set, then we come in here. We'll get to the other sockets later. We come in here. Now we can get to the accept. So we don't just accept a client a socket connection. We check, is there something to accept, right? So now we check if, is it FD is set? FD is set, yeah. If the listen socket, we now check if it's part of the read set, and this needs to be a pointer as well. Is it a part of the read set? If it isn't, then the listen socket doesn't have anything, there's no accept pending, right? There isn't anything to accept there. If it is, then we accept the connection. So now we can grab this and yeah. Right? So if the listen socket is set, then we accept the connection. Alright, so same thing as before, right? We have our client socket, so now we call accept, and it's a blocking call, but because select told us that it's ready, it shouldn't block, it should return immediately. So we call accept, we now get our client socket. If there's an error on accepting, if there's an error with the select, we break out and we're done the whole application. If there's an error on accepting, then we should do this at the end as well, right? Close the listen socket and then free the application. Oh, right. This is returning if there's an error or not. Okay, so we actually want to return false. Let me go back to main here. Why are we even doing this? I don't even check if it worked or not. I just call listen, then I end. So I don't think we actually need to return true or false here. I think what we could do, yeah, listen shouldn't even return true or false. I think it should just handle things properly. So that's a modification I'm going to make. Okay, so we do this. Now we accept the connection. We should be good to go. If there's a problem, that's that. Otherwise, we're good to go. We have our new socket. Now, this is why I wanted to get away from multi-threading. It makes things more complicated. Terminating the program is way more complex. Whereas with this, it's just a single thread, right? In a while loop, just continuously going through, right? We don't have all these separate threads. So it's easy to kill the application. In fact, actually my select might even have a I'm not sure how to interrupt that actually. Because that's one thing that's left, is I still need to be able to properly handle closing the application. When you kill the program in the command line or whatnot, it needs to close the application properly. So I just realized when we closed the socket, I didn't handle any of the closing of the socket on the when the server closes the socket, I didn't handle that to gracefully shut down. I didn't handle that properly. Okay, so here we have to go through each of the sockets. We have to go through all the sockets. Right. We're not going to need to do that now. We're not going to need to do this now. Right. So, accept a connection. You don't really need to do this. I mean, we're talking about like a handful of sockets at the most. We can just iterate overall and check if it's set. I don't really care about like the number ready. I actually don't really care about that. So technically, yeah, you would check if the number ready is greater than 0. I don't really need to check that though. Like, I don't really care. Right? If number ready is greater than 0 and it's set, then we do this. Decrement the number ready, right? Now we actually need to create our socket. Right? So this is where we actually create the socket. So socket ID is the next socket ID. We create our new socket. We create our new socket, set the ID, right, and then add it to the sockets, and then update the socket ID. Yeah, if I say So we just do that here, right? So we accept their connection here. Create our socket. And then normally what we're doing is starting up a new thread on the socket thread. Now we're not going to do this. So we've created a new socket. Now what do we do on that socket? Well, if we go to the socket thread, this is what we're doing, right? We're just waiting to receive data. This is now going to be moved out. Yeah, this is going to be moved to here. So what we do now is if this socket is set, then this number ready, you don't really need to do that, do you? I don't think you really need to do that. We can just check if it's set, and if it's set, it's set, and if it's not, it's not. Right, so we go through, that's the listen socket. Okay, so we accepted a new connection. But then we would also need to check all of the other sockets. And so that we would check if FD, okay, sockets, it's a map of the socket ID to a right. Okay, so we need to iterate over all of the sockets, right? Okay, so each socket, I'm gonna paste all this stuff. I know this is a bit crazy. I'm probably going to move this onto a separate function, right? Bind, listen. Accept connection. Accept connection. And then read. All right. Read. So we're gonna go through all the sockets, and then we want the actual socket. So we say socket, socket. No, this is second. So iterate over all the sockets. For each one, we will check if FD is set. So if it's set, if it's not set, we don't do anything. Right? If FD is set, then we need to read on this guy. This should be an external function. This should happen elsewhere, I think. Yeah, so what do we need here? Oh, it's just this. So socket accept. So it takes a listening socket, so do this. Right? I don't know if I'm going to use this number ready. Let's not do it. Let's ignore it. What the hell? I don't think it's necessary. I'm going to ignore it. Do all of this. So we add the socket to the set of sockets. It's there. So accept socket accept. So accept connection. Socket accept. If this is no, if this is the case, then we can just delete that, and then we check if socket accept passing the listen socket. If it's false, then we're going to return false, right? If it accepts correctly, we don't do anything. If it's false, then that's it. So num ready. Yeah, I think I'm not going to use this. Let's say we do. We just decrement it there. Right. Decrement number ready. Then we iterate over all the sockets. If it's not ready, it's not going to be set. So what's the point of really checking this? I'm going to go with my gut. I'm just going to get rid of all this. Not include that because I don't think I need that. And we'll see how it goes. So if the socket is set, then we're going to call socket receive. And we're going to pass in the socket. Right? Socket receive, and we pass in the socket. And this is what socket receive does. So socket receive, right? So what does it do? What does socket receive do? Well, we say receive the socket into the socket's buffer, right? And that gives us the number of bytes. And it's guaranteed not to block, right? Because we're ready to go. We don't need to lock anymore. If the number of bytes is greater than 0, then we actually received data. So we print this out. If the socket is already in a handshake, on socket data, we do this stuff. And continue means we just instead of continue, it's just going to be returned, right? If we're good, return. If we don't have a handshake, if the handshake was successful, then we do that. We don't have to remove this lock anymore. Right. Now, on handshake, we're going to check, do we have an onConnect method, right? And then we're going to handle this. If so, we don't need these locks anymore because it's a single thread. So we're going to call onConnect and do our thing. And that could end up calling send. We could send data on the socket, which I think will be okay. We're going to have to see if this is going to work. If it's 0, then the client has closed the connection. And so if the client has closed the connection, okay, or if not, then there's some kind of error. Either way, there's an error, and so we get to here, right? We get to here, and so we get the socket's ID. We then close that socket, try to close that socket. We then set socket closed to true, and then unlock. We don't need to do this anymore, I don't think, because we're actually just getting rid of this socket now. And then we have an onDisconnect method. Right? So onDisconnect, which socket was disconnected? But the socket's gone now, so you can't do anything with the socket. So we should actually delete the socket here and now, right? Yeah, we should just get rid of the socket here now, I think. I'm worried I'm going to really screw something up here with the different... I'm really hoping I don't screw something up here. So, I don't think we need closed anymore. I don't think we need that. Socket closed. Don't think we need that. We don't need the thread. We don't need the mutex. So that's made a lot simpler. So we don't need this. IO man IP, don't remember what that's for, but I don't think we need it. Am I using a queue? What's the queue for? I don't think I used the queue. So we close the socket. The socket's now closed, right? The socket's now gone. We should get rid of the socket. So at this point, I think actually what we should do is we've allocated that socket, right? We've allocated the memory of that socket. And that's why I passed in a pointer to the socket. We're going to free the socket. So free that socket. And then we're going to want to remove it from the list of sockets. Well, we know the socket's ID. Close the socket, free the socket data. We know this. Is there anything else on the socket that needs to be freed? No. We free the socket, and then we need to remove it from the list. So sockets.erase by key, or yeah, you can do by key. Okay, so erase, and the key is the socket ID. So we remove it from the list, we free the memory, that socket's done. Yeah, that's that. So that's socket receive. And there's nothing else to be done there. Now let's take a look at socket on socket data. Are we doing anything here? Yeah, so if on message is not null, then we want to handle a message. So we do that. Don't need these locks anymore, right? On socket data, on socket handshake. Okay, yeah. On socket handshake, okay. I think we might be okay here. We're gonna see. This might be a complete disaster. We're gonna see here. Where do I want to put this here? Socket accept, socket receive. So socket thread, that's gone. Right, I think. Yeah, we don't need this anymore, so we don't need to do this. So this is our method. It's pretty simple now, just a single thread. Bind it, listen, and then I'm just gonna say accept. This is where we accept stuff, and then this is where we receive. Right, and that's it. Go through the sockets, boom. If it's set, then socket receive. Once we're done, close the socket. Yeah, see, I think we need to do this here too. Right? Close it free. When we're done, we close the listening socket, we free everything. Before we do that, we need to go over all of the sockets. We don't need to do this anymore, right? Socket doesn't have a thread, so we can just delete. We can just delete that socket. Just free the memory, and then we go in and do this. Is there a mention of a lock somewhere? Yeah, when we send, we lock, so we don't need to do that anymore. Now, send to a socket and the ID. If you try to send and the socket's not there, invalid socket ID and it returns right. If the socket is there, we get that. We don't have this anymore. Right? Yeah, we don't have this anymore. Get the socket, and now we're going to write stuff to the buffer, and then we have a lock that we don't need. I don't think we need the lock. There's no mention of... Oh, right, there is. Okay. So that's that. Now let's see how things go here. This is Fenrir. Here we are. We have the mutex here. We can get rid of that. FD is set, is complaining. Yeah, because this takes a pointer. Oh, that's what... okay, so we do need... include IO man IP. Right? We're compiling and we're running. Okay. Disaster. Let's close the application. Let's see what's happening here. So, right. Okay. I'll just kill it, rerun. I guess it's still trying to connect. Okay. Anyway, it's trying to connect, I think is what's happening. Okay, so we come in here, we call select. Select never returns. Oh, no, it does now. Number ready is 1, that's correct. If it's set, it is. Accept the connection. And I guess the connection was accepted. Now, do we have sockets? Yes, we do. We have a socket. Go through the socket. It's not set. Come back here. Now we're waiting. So, okay, that all looks correct. So what's actually happening here? Socket accept. Is there a bug here? So we pass in the listen socket. Oh, is it because we accept the connection and then isn't it that aren't we supposed to call a function on connection, like on connection established? Did I delete that? Did I delete that? No, this wouldn't help me. I'm looking for Fenrir stuff. Shit. Okay. Alright, I don't have it as a Git repo. I screwed myself. What are you talking about? What are you talking about? Okay, I lost all that, so I don't know what's going on now. Okay, let me take a look here. On connect, right? On connect should be called. Wait a minute, we accept the connection, right? The connection is established. Right, before I was doing that, and then I received the data. Okay. Okay, that's the problem. So the problem is that we accept the connection, but then it's not okay, here's the first major hurdle I run into. We accept the connection, but then it's not seen as being set because it wasn't originally in the set. And so How do I deal with that? I mean, in this example that they have, they don't deal with it either. So they don't even use their total thing here anyway. But anyway, they accept the connection, but they don't then go in and read. So we accept the connection, but then there's also data that's sent, but for some reason that doesn't get flagged. So we accept the connection's established, but then the initial connection is an HTTP request, right? So it connects, we should get the connection, and then it should send us the data. But it never does that. It never even shows that the connection was established, which is weird. So normally we accept the connection and then we read, and right away we're getting data. Here we accept the connection. Is it because man, I don't know how to deal with this then. We accept the connection, then we get back to the select and then it blocks. Okay, wait, we may not be screwed. I made a mistake there. We clear the read set. We then add the listen socket to the read set. We don't add the other sockets. We need to then go for each of the other, for all the other sockets, right? Each one we have to say fd set kb second, which is a pointer, socket to the read set. So we accept the connection. Yes. Boom. Just a bug on my part. We are good to go. We come back in and then we add those sockets to the read set. And then that's that. This is really, really simple. I remember using select back in uni, and I don't think we used them in blocking mode. I think we used them in, I don't remember if it was blocking mode or non-blocking mode, but I remember using select, and that was the last time I used it. That was a long time ago that I used that. Okay, so we've got that now. Boom, we're here, we're getting our data. That looks good to go. Now, the only thing is I just need to test, sending and receiving data and seeing that everything is actually working correctly. That's actually kind of hard to test because I really want to check like concurrent things going on at the same time. Yeah, we have that here, we have that here. We have these sockets. If a socket disconnects, if I just close the connection, we're getting into a problem here. Right. So, okay, so here's the problem. We receive, we're iterating over the sockets like this, and that's not going to work because in socket receive, if there's an error, we remove it from the sockets. So we need to be able to tell... Okay, there's different ways we could do this. But we're at the 1 hour mark about, so we're gonna take a brief pause. Okay, brief pause. Okay, it seems to be working. Things seem to be working properly again. We can have multiple clients connected at the same time. That seems to be okay. We have this one problem here where we're removing a socket, right? If there's an error, when we receive data, if there's an error, then we're just going to close the connection. Actually, the front end does have to know that the socket was closed, right? Because... So how do we do this? How can we do this? Well, we're just iterating over the sockets. And then doing this. I think we could instead just use an iterator, and then when you erase, it gives you the iterator to the next one. Is that how it is? I've actually never done that with an unordered map. Sockets.begin. Wow, iterator is not equal to socket end. We increment the iterator, so then we don't say second, we say iterator. Is that how that is? I've actually never done this. Yeah, that's right. So iterator second gives you the socket. Why does this help us? Because socket receive, if so we could say so if it's set, we call socket receive, and if it's false, then there was an error on receiving some data, so we're going to remove the socket, right? We're going to destroy the socket. And so if there's an error destroying the socket, whatnot, then the iterator is now equal to yeah, this is more complicated still. How do I want to do this? I think, well, we should handle the receiving stuff here. So this receives the data, and if there's an error, we just say this, and then we return false, and then we handle that stuff there. So I think that's the solution here, is that we do, no, we do this, yeah, we do this, and then we come here, and okay, it's a bit confusing. Where are we here? Okay. So if we receive and it's successful, then we successfully receive data. We're good to go. If we didn't successfully receive data, then grab the socket's ID, close the socket connection, disconnect, right? We do this, and then we can do this here where we can say, no. We can say iterator is equal to, when we erase, it gives us, I think we can just give it the iterator. Erase this guy, and it gives us a new iterator. I think that's how that works. And if on disconnect, then we do that. Yeah. I think that will work. I just like how simple this is. It's just this one loop, single thread, and it's better for performance because theoretically, if you were going to have like hundreds of sockets, you're going to spawn up hundreds of threads. That's going to be really bad for performance. You wouldn't want to do that. You wouldn't want to spawn hundreds of threads. So, okay, so I think we need a while loop to do this, though. I think we need to say auto it is begin, and I think we need to do while wait. This is sockets. While it's not equal to sockets end, we do this. Right, else, if this is the case and it failed, so if we disconnect, then yeah, then we can do this, and then we don't increment the iterator. Otherwise, we increment the iterator. Wait, I want to do this. Is that how I want to do this? Disconnect, then continue. Oh, what am I doing? That's perfectly fine. So let's. Oh, socket receive. Socket receive needs to be have a Boolean return value now, right? So in this case, we return true because we're good to go. In these cases, we return false. Yes. Okay, boom. Let's connect with another client. Okay, and then we disconnect from here. We're still good to go, right? Client 2 disconnected, and we're still fine. I can disconnect and reconnect. I can connect a new guy. Okay. Now, if I kill the server, it just gets an error, right? No, it's not an error. Okay. This seems to be good. This seems to be good. So the select seems to be going well. Right? Select seems to be going well. It's all on a single thread. Everything seems to be good. Do I need to handle like a proper disconnect? I'm not sure. Okay, so let's do this now. This is all looking good. Let's get this working on Linux. So let's go back to TCP socket here, where we had our socket, our select here. I'm not using write, so technically I could remove the write as well. Yeah. I'll leave the write set there, but a brief pause. Okay, and we're back. So, should I get rid of this write set? Just leave it as is, doesn't really matter. This is meant for me to use it. If other people want to use it, they can modify it as they like. I guess I'll keep the right set there. But let's see if this works now with... It should work with Linux. The only reason it wouldn't is... well, the FD set's the same thing as well. Okay, this is confusing though. This thing is confusing to me. Yeah, this is something we still need to look at. I still don't get, because you aren't passing the socket, right? Are you? You're passing... It's just weird. You're passing in... This argument should be set to the highest numbered file descriptor in any of the 3 sets. Plus 1. So I think you would need to find the socket ID that's the biggest plus 1, and that's what you pass in here. Let's see if we can find an example here. Linux socket select. Right, so socket handle plus 1. But it's got to be the biggest socket handle. So we have to do a little bit of work there, actually. You can't just pass in a socket. Wait a minute, I'm thinking about this the wrong way. We're calling select on the listening socket. I find that kind of weird because you're specifying... Oh, I'm thinking about this wrong. It's the same thing here. NFD's parameter is included only for compatibility with Berkeley sockets. So you don't actually... This is actually ignored. It's only for compatibility with Berkeley sockets. So it's ignored. I don't know if it's ignored on the Linux one. It doesn't seem like it is. So because it's ignored, we could just do the same thing for both. And because it's ignored, if we go to Fenrir, I should be able to just pass in 0. Right? Well, no, this has to work with Linux, right? On Linux, it might be ignored as well. Let's see if we can find other examples. Yeah, because they have max SD here, right? Yeah, so max SD plus 1. This is just weird because they're setting... That's very strange to me because they're setting the max SD here to be the listening socket descriptor. So you have the master set and then you have the working set. Here you pass in the working set, which also has the master set, right? unless max SD is updated. Right, okay, so, okay. Well, we'll do it. We'll assume that it's needed for Linux, but we'll do it. So what we need to do is we need to keep track of the largest, the highest valued socket ID. Well, wait, it has to be the biggest one in this set plus one, so I could just iterate over this set, figure this out, right? Technically. Because at the end of the day, this set, it just has an array of sockets, right? I'm not sure what this is in Linux. It says you need to include select. But they're not doing the socket stuff, so maybe it's already included in there. Is the highest numbered file descriptor in any of the three sets plus one. I'm just going to do it that way. So mine's not going to take anything here. You're just going to pass in the read set and then the write set. And then my select method will do that for us, right? So select doesn't actually take this. It takes a read set, write set. Number ready, I don't think I actually care what the number ready is. Are other people using that here too? I'll keep it there just because, but yeah. Instead, what I could do here is pass in a pointer. NumReady is a pointer. Yeah, I could do that, so I just dereference that and set it to there if it's passed in. So if you pass that in, then do this. Alright, let me tell you how many are ready, otherwise we just ignore it. Ready. Okay, so how do we do this then? We have to iterate over each set. So how can we do that? Well, we should be able to say for read set I got to be careful here though, because here it's FD array, but I don't know what it is. FD. Well, Windows, we don't have to do this, so we only have to care what it's called in Linux. So what is it called in Linux? I need to look at this struct in Linux. FD set. Oh, in Unix it might just be bits. I think in Unit, right? That sounds familiar. In Unix it's just bits. FDset just has bits. Man, this becomes a real pain in the ass. Can't do this. So for Windows, For Windows, we just do this for compatibility reasons. That's the thing, I don't really know what FD set is. Oh, wait a minute. It's defined in select. Okay. Yeah, this is kind of a pain in the ass. Okay, so if we go back to Fenrir, so now I can just do this, and then num ready. I don't care. So I'll set this to null point. So TCP socket. And we got connections, terminate. Okay. Now with Linux. Yeah. I don't know why I can't scroll up anymore. I don't know what's going on there. Oh, I think it's because, right, it's my NeoVim configuration of it. If I do Ubuntu, is that the same? Yeah, okay, I'll use Ubuntu. Holy shit. Okay, that's a lot of errors. I deleted something. I deleted something here. This was working not long ago, so I deleted something major here. Oh, I don't have vector here. I don't have vector here, that's correct. Boom. There you go. Okay. How come I'm not seeing those warnings that I had before? So now we have this. So if I say main.exe, we're running. And if I try to connect, yeah, it doesn't work. Yeah, it doesn't work. Okay. I think that's because of this. I think that's because of this. Yeah. Like the implementation of FD set and all that. Worst case scenario, I'll just have to track what the largest one is, but wait a minute. The select function checks only the first this many file descriptors. The usual thing is to pass FD set size as the value of this argument. Oh. Yeah. FD set size. Let's try that with Linux. FD set size. That compiles. There we go. Okay, so I think we can, we don't have to worry about that then. Yeah. And if somebody drops off, client 2 disconnected, and then I can disconnect. Okay, so what does that mean? Well, I don't think FD set size will be there for on Windows. Oh, it does, right. It does have this. So this would work on Windows or Linux. It seems it will. Okay, I hope I'm right about that. Okay. Okay, so that's good. That's really good. Okay. So everything seems to be working right. Okay, we have the client, we can connect, we can send data and whatnot over. The last thing I really need to handle is a graceful shutdown of the application. And what that means is we're running, right? We're running here, we're fine, everything's good. Now, if I'm running on the command line or whatnot and I kill the application, I need to know that the application's been killed so that I want to be able to, it's not a must-have, but I'd rather do that. I'd rather be able to handle that, break out of this loop, close the listening socket, free everything we need to, free all the data. It would be nice to do that. Yeah, it would be nice to be able to do that. If I try running this again, it doesn't end up getting. I thought I'd have a problem where this socket can't bind, but that's not a problem. It would just be nice to be able to do that. So how can we do that? What we could do now is we could actually specify a time interval that's very, very, well, it just has to have a time interval so that when you actually kill the program, within a few seconds it actually kills the program. So maybe like a second. So what you could do is you could have select wait for a second. If it doesn't get anything for a second, it then just exits, comes back again, waits, it'll wait for a second, then it'll come back again. I think that's fine, and that way when it waits and it breaks out, we could then check, has the program been terminated? Did we get a command to close the program? Right? Now how do you do that? Again, Windows and Linux. How do you actually do that? Yeah, but do I have to start dealing with a Windows signal? Right, like the control. So how is this going to be running? Well, I'm going to be running it on Visual Studio, and then when I'm done testing it, I'm just going to kill the application like that. Or it's going to be running on a Linux server, and to kill it, I'll have to send like a process kill command to it. Let's see how it is on Windows then. Either closing either closing the window or that. Let's see what signal I get. So let's see an example of this. So you just say signal this and then the handler. Gonna put this over here. So so let's but you have to use the signal header file. Do you really have to? But does it override the call? That's what I'm wondering. Well, we'll see. Handle signal takes a signal. Just gonna put that there, and then what we're gonna say is just here signal handle signal. And the signal we're gonna be handling is abnormal termination, termination request, sig term. And then let's also do sig int. Now in here, I'm gonna come in here, put a breakpoint on there. Yeah, so we need to include signal. Doesn't know what we're talking about here, and this is Windows specific. I'll separate it here just to make that clear. Signal.h. So we're running. If I hit this, nothing. If I hit this, nothing. What if instead I just say, hey, what are you gonna see it? I don't think it overrides it. So yeah. So on window close signal. Control close event, which you could catch and process if you set a control handler. You set control handler. Set control handler. It takes a handler routine, add as a boolean. If this parameter is true, the handler is added. Otherwise, it's removed. If the handler routine parameter is null, a true value causes the calling process to ignore this. Okay, so return is non-zero. It pointed to an application-defined handler routine function to be added or removed. So we want to call set console control handler. So set console control handler. Is that right? Set console control handler. Yeah, our routine is handle signal. And then we're passing in true. Right? Now the routine, what does the routine have to look like? Handler routine, it takes in a word. Control type, it takes that as a word. As a double word. Oh, and it has to return a boolean. I don't know what the hell that's supposed to return. Maybe any of the following. Control whatever. Okay, return value. It should return true. If it returns false, the next handler function. So it should just return true. Right. This is a function pointer, bool, a double word. control type. Handler routine. What's the problem here? Argument of type is incompatible with parameter of type p handler routine. I have to say this. Okay, right. So if I click this, hey, we get to here. And then you just keep running, and then it closes. Now I'm curious if I hit this. Yeah, it doesn't stop debugging. But I guess I'll just close it this way gracefully. But it's still going to terminate the program. That's the thing. So I know this is probably all overkill. I don't even need to do this and everything will probably work. It doesn't seem to be... The socket can still be bound. I don't think I really need to do this. But I'd like to do a cleanup of everything if I can. So... And this is it. Once this is done, everything's looking good. I'm not going to really know if there's problems until I actually start using it with converting the game over that I have from Node.js to this. So that's really the next step. So this is really this is it. The Fenrir is ready once this is done, really. I haven't really worked with these kind of process exit things. Because the system creates a new thread in the process to execute the handler function, it is possible that the handler function will be terminated by another thread in the process. Be sure to synchronize threads in the process. Each console process has its own list of handler routine functions. Initially, this list contains only a default handler function that calls exit process. A console process adds or removes additional handler functions by calling the exit process. The exit code for the process and all threads. Handler function by calling which does not affect the list of handler functions or other processes. When a console process receives any of the control signals, its handler functions are called on a last registered, first called basis until one of the handlers returns true. If none of the handlers returns true, the default handler is called. So I am returning true, so it shouldn't take the default handler. To clean up before termination. A handler routine can perform any necessary cleanup. Then take one of the following actions. Okay, here's the thing. What do we need to do? Technically, what we need to do is free all the memory of the sockets. And we could have the listen socket up here, right? We need to free the memory of the sockets and then just close the listen socket and close and then free our stuff, right? So technically we could do that, right? Let's see if this works. Yeah. So what we would need to do is the TCP socket would be here, right? The listen socket. So we have the listen socket. So we would do, right, if there's any error here, I think we have a terminate function, maybe. terminate. Or we should have our own free method. And what we do in here yeah, what we do in here is go through each of the sockets, free it, close the listen socket, and then free that. So if we get to here, we call free. Right? If there's some kind of problem, we call free, right? And so in here, if there's a problem on select, yeah, I don't think we need to do that. We can just, if there's a problem on select, we can just break out of this, right? Right, we just break out, and then it will free everything. And there's no returning true or false. I don't think we need this at all. I don't think we need return true or false, right? I think we just say return, right? So if that happens, just free it. That happens. Failed to listen. So if we failed to bind it, it couldn't create it or whatever, we free it. If we failed to listen, yeah, there's nothing else to do, just free it. TCP socket free. Just free the TCP socket. Otherwise, we're already listening, so yeah. I don't think there's gonna be a boolean. You call listen, and it will just block. Well, okay. I think we should actually have a bool, because then, yeah, we should have a bool, because then we can know right away if it's properly listening or if it's not. So if there's a problem while it's doing this, it runs into an error. Well, technically what we could do actually here is, technically what we could do is we just call free and then we return false. It did not, false means it didn't terminate properly. Just free and then return false. So false means something went wrong in the application and it terminated. This just means if it's true, then that means it ran and then shut down properly. So free, we go through, close the listening socket, free everything, go through all of the sockets, free the memory, but also try to close the socket, I guess. TCP socket close. So free is going to be a method here. And handle signal, what do we do? We just call free. So we're running. If we close it, I think everything seems to be okay. Exception thrown, and we don't know where. What was the exception? We're connected. If I do this, failed to receive client socket data. Is that because we're trying to close this? Is that what's going on? Is it because I'm trying to close the listen socket and it's actually listening? And it's stuck on select or something. Failed to accept socket connection 6. Wait a minute, is it because select is returning? Yeah, I don't know. Maybe I'm not gonna do all this. What do they do to clean stuff up? They don't really actually do anything. Close the socket. Free socket information. Let's see if there's an error. Alright, I think I'm not gonna do it. It doesn't seem to be a problem. It's not if it becomes a problem, I'm gonna do it. I'll go in and I'll make the necessary change. But well, that I can keep there. I can keep the listen socket here. But this I'll delete. Don't need that. Yeah. Yeah. So free still like that. And connect. If we try to compile and run it, we are running on Linux, and if I kill it, good, I can, yeah, okay, see, failed to bind the socket, address already in use. If anything, maybe not for Windows, but for Linux, I really want to catch when I'm getting the kill command so that, because I think I need to close the listening socket, right? I can't bind to it again. But on Windows, I can always do it for some reason. I'm not sure why. And I'll kill the application. And then if I try it, it's weird. I still can't bind to it. But then I think if I, yeah, I still can't bind to it. Yeah. Address always already in use. Yeah, this is really a problem that I want to fix. Or we could just look up more generally Linux socket. Um, Tap to reconnect is waiting for completion. It returns -1. Oh, so a blocking call. Well, select is a blocking call, so when you kill it, it should get -1, and then you should get an error, right? So for example, like, let's say we're just waiting on the select, you should get an error, so this should be false, which we should see failed on select, and then we should free everything, which should close the listen socket, right? Yeah. So sig action, they're just setting everything to 0. Set the handler flags, and then sig action, sig int. The purpose of pslice is to atomically unblock some signals. Wait for IO as select does, and reblock them. So p select. Now it's working. It just takes some time. I may wait for and do this in another video again. Handling termination properly, because it's pretty involved, and it's something I haven't really done before. So this may take a while. Yeah, so what's weird is if I do this, it will always still work. So I'm just killing the application, yet I can still bind that port again. The problem happens if I'm binding on Windows, then I kill the application, and then sometimes when I come in here, it won't work. But sometimes it will. And maybe that has nothing to do with shutting down. So I'll defer this, and we'll do this another time. I'm just thinking if there's anything else that needs to be done, because Fenrir basically is ready to go now in terms of being used as a WebSocket server. And here's another thing: I may not call it Fenrir. I might just call it WebSocket.h. I'm not sure yet if I want to call it Fenrir or WebSocket. Yeah, maybe I'll leave it as Fenrir, I guess. But because this is basically what you're doing now. You know, server description. You set your port. You set your callbacks. You start listening. And then it runs this WebSockets server. People can connect. Then you can just handle these methods. So on socket connect. So we have a connection, and then you can send data. When we receive a message, we can do something with that, and then we can know when we had a disconnection. And that's basically it. There's not much to it. Yes, this is a bit tedious having to deal with this kind of stuff, JSON, but it is what it is. I think Fenrir is basically ready to go now. TCP socket now has an additional select method. Yeah, I think we're ready to go. The next test to really know if there's any problems is when I'm actually using it in my game. That will show if there's problems or not. So I think that will be it, and gracefully shutting down the application, I'll defer that, and maybe I'll eventually do that. If I don't think I need to, maybe I won't even bother doing that. But if so, that'll be done in the future. Yeah. Okay. So that's it. Fenrir is basically complete. It's now time to actually use it and test it out and see how it goes. But I think Fenrir is actually complete. So, yeah. I think that's it. Which means what's going to be next? What's in the next video? Well, that's going to be a bit of a surprise. Yes.